Look up at the night sky. What do you see? You see a vast dark canvas sprinkled with countless tiny lights. Each one of those lights is a star, a sun, and many of them likely have planets orbiting them. For as long as we have been human, we have stared at those stars and wondered. We have told stories about them, named them, and dreamed of one day visiting them. This is a dream that lives deep within us, a fundamental part of our curiosity. We imagine starships gliding silently through the void, carrying explorers to new worlds, just like in our favorite science fiction stories. It is a beautiful, powerful vision of our future among the stars. This dream of interstellar travel is one of humanity's oldest and most persistent ambitions. However, there is a giant, unyielding obstacle standing between us and that starry future. It is called distance. The sheer scale of the universe is almost impossible to comprehend. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. With our current rocket technology, a journey there would take tens of thousands of years. The search for a new fire. Our entire civilization is built on energy. From the first fire that warmed our ancestors to the electricity that powers our modern world, our progress has always been linked to our ability to harness new energy sources. We have burned wood, coal, oil, and gas. We have learned to split the atom to release nuclear energy. Each step has unlocked new possibilities. This is the great paradox of our time. We live in a universe that is brimming with energy. Every star is a colossal fusion reactor, pumping out unimaginable amounts of light and heat every second. Yet here we are, stranded on our small blue planet, feeling like we are running on fumes. We are like shipwreck survivors on a raft, surrounded by an ocean of undrinkable salt water. What if the solution to our energy problem is all around us, yet completely invisible? What if the universe contains a hidden reservoir of energy, a substance that we cannot see, touch, or feel, but which holds the key to interstellar travel? This sounds like pure science fiction, but it is an idea that physicists are taking very seriously. This mysterious, invisible stuff has a name: dark matter. We know it exists because we can see its gravitational effects on stars and galaxies, but we have no idea what it actually is. Astronomers discovered dark matter not by seeing it, but by observing what it does to the things we can see. They noticed that galaxies were spinning much faster than they should. The only explanation was that there must be a huge amount of unseen mass, a dark matter halo, providing the extra gravity needed to hold everything together. Imagine you are baking a cake. You follow the recipe perfectly. You add flour, sugar, eggs, and butter. You mix it all together and put it in the oven. But when you take it out, the cake weighs 5 times more than it should. There must be something else in the cake, an invisible ingredient that you didn't add, but which somehow makes up most of its weight. This is precisely the situation astronomers find themselves in when they look at the universe. It's called dark for a very simple reason. It doesn't seem to interact with light. It doesn't shine, it doesn't reflect, and it doesn't cast a shadow. It is utterly, completely transparent. Think of it like a ghost passing through a wall. It is there. It has mass, but it sails through ordinary matter without leaving a trace. If we can't see dark matter, how can we be so sure it exists? Well, the answer lies in gravity. While dark matter may be shy and elusive, it just cannot hide from the fundamental force of gravity. The first big clue came from observing galaxies. An astronomer named Vera Rubin noticed something strange about the way they spin. She saw that stars on the outer edges of spiral galaxies were moving just as fast as stars near the center. Another powerful piece of evidence comes from something called gravitational lensing. Einstein's theory of general relativity tells us that massive objects can bend the fabric of space-time itself. This means that gravity can act like a lens, bending and magnifying the light from objects behind it. We can see the warping effect of dark matter's gravity on the light traveling across the universe. Knowing that dark matter exists is one thing, but finding out what it is made of is another challenge entirely. This has become one of the most intense and exciting quests in modern science. One approach is to go deep underground. Scientists have built incredibly sensitive detectors in old mines or beneath mountains. The hope is that just once in a while, a single dark matter particle will, by pure chance, collide directly with the nucleus of an atom inside the detector. Another way to hunt for dark matter is to try to create it ourselves. At places like the Large Hadron Collider at CERN, Physicists smash protons together at nearly the speed of light. We wouldn't be able to see these particles directly in our detectors. Instead, we would look for their signature energy and momentum that go missing from the collision, as if something invisible carried it away. We have established that dark matter is everywhere. It fills the cosmos, surrounds our galaxy, and streams through our planet and our bodies every moment of every day. So if there is so much of it around, why is it so incredibly difficult to get our hands on? The problem lies in its fundamental nature. Dark matter seems to ignore almost everything we consider to be reality. They are so indifferent to our existence that they pass through solid rock as if it were empty space. Let's assume for a moment that our brilliant scientists succeed. Imagine they finally detect a dark matter particle and confirm its existence. This would be a Nobel Prize-winning discovery, changing physics forever. But for our dream of a starship, this is only the very first step. Detecting a single particle every few years in a giant, expensive detector is one thing. Collecting enough of it to power a city, let alone an interstellar vehicle, is a challenge on an entirely different scale. Some science fiction concepts imagine a starship with a giant scoop on the front. As the ship travels through the galaxy, this device would funnel in the dark matter particles that permeate space. This is a beautiful idea because it means the ship could refuel as it goes. So let's continue our journey of imagination. Let's say we have solved the detection problem and the capture problem. Our futuristic starship now has a tank full of bottled dark matter. What next? The fuel is useless unless we can get the energy out of it. For dark matter, the most talked about method for energy release is annihilation. This is a process where a particle of matter meets its corresponding antiparticle, and they both vanish in a burst of pure energy. The reactor core would be a tiny, intensely powerful furnace. It would not be made of metal, which would instantly vaporize. Instead, it would be a magnetic bottle of the most extreme kind, or more likely, a containment field woven from pure gravity. The raw output of this annihilation would be a chaotic spray of high-energy gamma rays and other exotic particles. The engine's next job would be to convert this radiation into directed thrust. The challenge of forcing dark matter particles to annihilate each other is so great that scientists have imagined clever workarounds. What if you didn't need to smash them together with brute force? What if instead you could use a catalyst? In this futuristic concept, a dark matter catalytic converter would use ordinary matter to trigger the annihilation. The idea is that dark matter particles, while reluctant to interact with each other, might be more likely to interact with certain types of heavy, dense atomic nuclei. As we venture further into the realm of speculation, the ideas become even more extraordinary, really blurring the line between theoretical physics and, well, pure imagination. One such idea combines the dark matter scoop with the annihilation engine in a more direct and elegant way. This is the dark matter ramjet. In this design, there is no collection tank or complex reactor core. Instead, the collected dark matter is funneled directly into a compression chamber where it is forced to annihilate, and the resulting energy is immediately channeled out of the back of the ship as thrust. Taking a step even further, some theories propose using one of the most extreme objects in the universe as a power source, a black hole. A tiny, microscopic black hole, perhaps with the mass of a mountain but the size of an atom, would be created and carried in the heart of the starship. This black hole drive is perhaps the most powerful engine imaginable. It could theoretically convert matter to energy with nearly 100% efficiency. This is a concept so advanced it is almost godlike. Our dream of traveling to the stars is not tied to a single technology. The quest for a powerful new engine has inspired many brilliant ideas, each with its own set of promises and problems. Dark matter propulsion is a fascinating but highly speculative contender in a race filled with other futuristic concepts. First, there is nuclear fusion, the power source of the stars themselves. This involves fusing light atomic nuclei together to release energy. Nuclear fusion is often seen as the next logical step in human energy production. If fusion is the next logical step, then honestly, antimatter is the ultimate leap in terms of raw power. Antimatter is real, it's not science fiction. When a particle and its antiparticle meet, they annihilate completely, converting their entire combined mass into pure energy. However, antimatter comes with two almost insurmountable problems: production and storage. The slightest containment failure, even a momentary power flicker, and the antimatter would touch the walls of its container, resulting in an explosion that would make a nuclear bomb look like a firecracker. When we place all three contenders side by side, a fascinating picture emerges. Each represents a different philosophy for conquering the void. Fusion is the workhorse, antimatter is the sprinter. And what about dark matter? The dark matter drive is the wild card, the ultimate explorer's engine. In the end, there may not be a single winner. Perhaps our future in space will rely on a combination of these technologies. The race for the stars is not just about choosing one engine. It is about building a toolbox of possibilities for the greatest journey humanity will ever undertake. We began this journey by looking up at the night sky, feeling the ancient human pull of the stars. We have traveled through the heart of modern physics, exploring the ghostly nature of dark matter and the immense challenges that stand between us and using it as a fuel. What would happen to humanity if we unlocked the secret to dark matter propulsion? The answer is simple and transformative. Everything would change. Harnessing dark matter fuel would not just be another technological step forward, like the invention of the steam engine or the aeroplane. It would be a species-level transformation. The tyranny of distance, the great cosmic cage that has confined us to our homeworld for our entire existence, would be broken. Journeys that currently seem impossible, taking tens of thousands of years, could be reduced to a human lifetime or perhaps even less. The stars, which have forever been distant, untouchable points of light, would become destinations. Humanity would begin to branch out, to settle new worlds orbiting other suns. We would evolve into a multiplanetary and then a multistellar species. The pursuit of dark matter, whether it ever leads to a starship or not, is already teaching us something incredibly valuable. It is teaching us humility. For centuries, we have looked at the universe and catalogued the things we can see, the stars, the galaxies, the gas, and the dust. And yet, the discovery of dark matter has shown us that everything we can see, everything we have ever known, makes up a mere 5% of the cosmos. We are, in a very real sense, living in the froth on the surface of a vast, dark, and mysterious ocean. Furthermore, tackling a problem of this magnitude pushes us to be better. The hunt for a single, elusive particle requires unprecedented global collaboration. This is science at its best, transcending borders and politics. It is a model for how humanity can unite to solve its greatest challenges. So, is dark matter fuel science or science fiction? For now, it remains firmly on the side of science fiction. The obstacles we have discussed, detection, capture, and annihilation, are monumental, each requiring breakthroughs that are currently beyond our grasp. It is a beautiful, tantalizing dream, but a dream nonetheless. It is a concept that lives in the far future, a goal for our distant descendants to perhaps one day achieve. But we should never underestimate the power of such dreams. It is by dreaming of the impossible that we often achieve the extraordinary. The journey towards a dark matter engine, even if we never reach the final destination, will pave the way for other incredible advances. Just as the Apollo program gave us countless technological spin-offs that we use in our daily lives, the quest for a ghost particle will undoubtedly yield rewards we cannot yet foresee. Ultimately, the story of dark matter fuel is a story about hope. It is the hope that we are not permanently trapped here. It is the hope that humanity's future is not confined to a single fragile planet, but is written in the stars. From our vantage point today, on this pale blue dot, the challenges seem immense. But history has taught us that the impossibilities of one generation often become the realities of the next. And so, we continue to look up at the sky, to wonder and to work. The truth about dark matter fuel is that its greatest power, for now, is not to propel a starship, but to propel our imagination towards a future worthy of our potential.